Let's discuss the question number 8 from TS4. It is from thermodynamics. Basically the IC engines part. Okay, so what is given? The radius of the crank in an engine is given. Let's denote it by R, and it is given as 3 centimeter. The diameter of the piston, let's denote it by capital D, which is given as 6 centimeter, and the swept volume of this single cylinder engine is asked. So that is V. That is what is asked. So what is swept volume? The swept volume is, if you take a single cylinder and the space or the volume between the TDC, the top dead center and the bottom dead center, the extremes of the piston travel, so that this volume, the volume that is enclosed between TDC and BDC, the top dead center and the bottom dead center, that volume is called as the swept volume. So this is nothing but basically the area of cylinder, because that's the cylinder that is enclosed between TDC and BDC. So that is nothing but, let's start from the beginning, which is area of cross section into the stroke length, which is let this be stroke length capital L. Okay, so stroke length is L and area of cross section is A, which is nothing but, as it is circular, so it is pi by 4 d square into L. So now D is given, L is not given, so L we need to find out. So what additional information is given is the radius of the crank is given. So let's build up a line diagram when the piston is at TDC. So when the piston is at TDC, let me draw this. This is TDC, this is BDC, and this is my, what will happen is my crank length, my connecting rod and the crank will be aligned when the piston is at TDC, and they will be aligned in this way. So let this be O. Okay, and now let me just draw another position where the piston is at BDC. So this is my piston which is at BDC. So remember, this may not be exactly BDC and this are not same, though it looks same in the figure, but these are all different. So my R will be somewhere here, and the connecting rod, some portion will be over the incline. So it's something like this, or let me draw sideways, something like this. So this is my length, because the radius of the crank will be 180 degrees. It would have traveled from this position, from the first position to the second position, and this is my O. Okay, this is my O, this is my radius, this is my crank, and this is my connecting rod. Okay, now, and okay, so this is my BDC. Now the distance between TDC and BDC, as we know, that is capital L. Okay, don't confuse with the small l. Small l is the length of the connecting rod, capital L is the stroke length. Now what I will do is, I will equate the distance between O and TDC in both the figures. So between O and TDC, the distance here is L plus R, and the distance here between O and TDC is basically my stroke length plus this distance, which is L minus R. So it will be capital L plus L minus R is the distance between O and TDC in the second figure. So this gives rise to L is equal to 2R. So this is an important observation in the single cylinder engine, where length of the stroke length basically is twice the radius of the crank. Okay, so which is given as 3 centimeters, and so this is equal to 6 centimeters. Let's substitute. So now we know everything. Now so swept volume Vs is basically pi by 4 into D is 6 centimeter whole square, and stroke length, which is L, is 6 centimeters. So this, when I use a calculator, it comes out to be 169.6 cc, centimeter whole cube. So this is approximately equal to 170 cc, and therefore the answer is B. Thank you.